right? So which follows the client server architecture, okay, which follows the client server architecture. So if we want to increase this server capacity, we need to scale vertically, okay. So which is more costly, right? And the compute is limited to this machine only, which is a single node, right? And for example, if we take any of the big data technologies, we'll be having multiple different machines which will contribute for the compute and storage parallelly. Okay, so that is the reason the distributed computing comes into the picture. Okay, distributed computing will really fasten the data storage and processing power of big data. Okay, so that is where we came from the single node client server architecture to the multi-node distributed architecture. Be very very clear, multi-node distributed architecture. So what we'll be having in multi-node, there will be master node. Node means server. Okay, node means server. There will be a master server, and there will be multiple worker servers. Okay, so worker server 1, similarly worker server 2, worker server 3, worker 4, or 5, worker 6. Okay, now the client request will come to the master node. Okay, the request will come to the master node. Now master node, what it will do, it will coordinate with all the worker machines that we have in the system. Okay, it will coordinate with all the worker machines that we have in the system, and then it will make every worker work on the request came from the client. Okay, so that is what a distributed computing, be very very clear, which is different from our traditional client server architecture. Okay, which is different from our traditional client server architecture. Okay, so in this architecture, this is a traditional architecture wherein your Oracle, SQL Server, all these database systems will follow this architecture. Okay, but when it is big data, or if it is Hadoop or Spark systems, right? So then they will run on top of this architecture. Okay, which is cluster architecture. Cluster meaning group of machines or group of servers connected in a single network. Be very very clear, group of machines or group of servers connected in a single network, that we call it as a cluster. Okay, so your Oracle, SQL Server, data stage, Informatica, every technology that is there, uh, as a traditional data engineering technologies, right? They all belongs to your client server architecture. Okay, they all belongs to your client server architecture. That is why they are lagging in processing big data. They are lagging in storing big data. Okay, so that is the reason uh, these R&D scientists, they invented this big data systems called Hadoop and Spark. Okay, so these systems will run on top of a cluster. Okay, that is why we call them as distributed computing technologies. Okay, distributed computing technologies, that means a task will be completed or processed by multiple different machines. Okay, so you just assume you have a machine which is actually the single machine, or else you have a human being which is who is capable enough to handle 50 kgs weight, right? So if we give 70 kgs for that human being, what will happen? So he will fall down, right. For example, we are giving 70 kgs weight to that human being, and we'll add one more human being to support, right? To add one more human being to support, then what will happen? So those two human beings will start lifting that 100 kgs or 70 kgs, which is beyond the limit of one human being, right? So that is why, as and when the requirement comes in, we can add more power to the system. That is distributed computing, right? So all the human beings are working parallelly, so that is what parallelism, right? Parallelly they are completing their task. Okay, so he is also giving his hand and he is giving his hand, and they both collaboratively, parallelly supporting that weight, right? So parallel and distributed computing, these both are very important in a big data world. Okay, so we use distributed computing for parallelism. Okay, remember, we use distributed computing for parallelism. That means we parallelly make all the workers run to accomplish the client request. Okay, so that is the difference between your client server architecture and then your cluster architecture. So cluster meaning your group of machines connected in a single network. Your big data technologies like Kafka, Hadoop, Spark, NoSQL databases, everything will run on top of a cluster. Okay, remember, these technologies will run on top of a cluster. Okay, in that cluster you will be having group of machines. Okay, if that cluster capacity is not sufficient, then what you'll do, you'll simply add nodes to that cluster or machines to that cluster. Okay, anybody have any questions? Are you able to understand the difference between the client server and distributed architecture? We'll go to the Dataproc and Spark later, but you need to understand what is distributed computing first. Okay, so any questions here, guys?
Clear.
Clear.
Okay, Anusha, Ranganath.
No, Venki.
Okay, okay, fine. So that is what distributed computing is. Now, okay, so now by this time we know our Spark and Hadoop, all the systems will run on top of a cluster. Okay, now in GCP, for implementing the Spark and Hadoop based applications, we have one service which is Dataproc, correct? So in Dataproc, how we create these clusters is something that we're going to see first. Okay, because we have, when we want to build Hadoop and Spark applications, we need a cluster environment, correct? So on top of the cluster environment only, these technologies will run. Okay, so now these technologies we can implement in Dataproc service in GCP. In Dataproc, how we create the cluster, right? So let us quickly understand how we can create cluster in Dataproc. See here, we have Dataproc service. People who did not open it, you just try to search Dataproc here and enable that API, Dataproc API. You will get this page. Okay. Now in this page, the first and foremost task that we need to do is we need to create a cluster. Okay, we need to create a cluster. So how we will create the cluster? How we will create the cluster? For that, we have two options. We have two options. One is creating the cluster from the UI. Okay, creating the cluster from the UI, and creating the cluster from a script. Okay, so I don't recommend to create the cluster from the UI. The reason being, not always you will get the access to the UI. Okay, not always in the projects, real-time projects, you will get the access to the UI. In production environments or in test environments, you don't get UI based access to create the clusters. Okay, you have to use a script based fashion to create your Dataproc cluster. Okay, so now let us quickly understand how we will create a Dataproc cluster from a script by using a script or a command, right? So if we want to execute commands in a GCP project, where we need to go, we need to go and open our notebook. Okay, Vertex AI notebook. Okay. Now once we came here, The first and foremost step that we need to do is we need to prepare our we need to prepare our one minute, guys. Just give me a minute. I got some message. Okay, fine. So, how we will actually create a cluster? So, in today's session, we will try to create a cluster using a command line interface or a script interface, right? So, let us quickly see how we can actually do that, right? So to execute commands, right, so to execute commands we have to go to our vertex AI notebook. So this is the only place where we can trigger our gcloud commands, right? So for everything we have gcloud commands, so we can actually use that commands to create the clusters. Okay, so here if you see I have a gcloud command, okay, to create the cluster. Now let us understand what is this command and what are the parameters that we have given, right? So here if you see gcloud data proc clusters create, okay, this is the command, and your cluster name I'm just giving as jobs cluster. I'm enabling the component gateway. This is the network related user interfaces. If we have any external links that we need to access from the cluster, so this enable component gateway will help us. And in which region you want to create the cluster, okay, and the master hyphen hyphen master machine type, okay, and I'm giving it as n1 standard 2, okay, n1 standard 2. So what are these machine types we will see after the cluster creation, okay? And the boot disk, the ssd disk space, how much I need 50 GB. And the worker machine type, that means the worker machine, what type of machine you need, I need n1 standard 2, okay. And worker boot disk, the disk space for the worker, I'm giving it as 50 GB. And number of workers, I need two, because less than two it won't allow. We should maintain at least two workers in a cluster. And image version, right? So this is a repository, you can say, wherein all the Spark, Hadoop, Hive, all these technologies are packaged together, and they just image them, and they'll place it in the repository. Okay, Google Artifact repository, that image version that we are keeping. Okay. And project we need to specify. And the bucket, default bucket, because if you want to access your GCS files from your data proc, you need to specify this bucket. Okay. And the service account, uh, this you need to specify. And then the optional components, okay, the optional components you need to specify the Jupyter. Because if you see in our notebooks, we were able to open these notebooks, right? Jupyter notebooks and Python notebooks, all things we were able to open because it has a library or a package called Jupyter installed. Similarly, in the cluster also, we want to communicate to the cluster, right? So for that purpose, we need this Jupyter. So that is why we passed this Jupyter at the time of installation itself, so that it will create the cluster. Okay. And here, this N1 standard 2, N1 standard 2 is the machine types. Okay. In GCP, your compute machines have different types. Okay. Meaning the memory optimized machines, and CPU optimized machines, right? So there are a lot of segregations, general purpose machines. So depending on the machine type, you will be charged in the cloud. Okay. Whatever the machine type that you are selecting, depending on that, your compute charge will be handled. Okay. So what all the types of machines that we have, we will see. Okay. But this is one of the type, which is N1 standard 2. Okay. So this is one of the type. Like that, you have N1 standard 4, 6, 7, 32, 8, 64, till 64, 128 also you have. Okay. Similarly, you have N2 standard, E2 standard, and C2 standard, C3 machines you have. So different types of machines are there. But remember, the cost will vary from machine type, N1 to N2, N2 to E2. So depending on the machine type, the cost will differ. Okay. So let's quickly create our data proc cluster. So I'm just opening my terminal, and I'm just simply pasting my cluster creation command. Okay. So once I click enter, what it will do, it will start creating your cluster, guys. See here, waiting for the cluster creation. Okay. Meanwhile, we'll just go and see the machine types in GCP. Okay. So we just need to understand this very clearly, because these machine types, are very important in data proc. Selecting proper machine type will reduce a proper lot of cost in data proc. Okay. If you see here, N4, C4, X4, N2, E2, C2. These are all different machine categories. Fourth generation machine series, third generation machine series, second generation machine series, right? So high CPU, right? High CPU from 1 to 3 GB memory per vCPU, typically 2 GB per vCPU. So these are all different memory, high mem, mega mem, right? And hyper mem, ultra mem. right? Standard. So these are general purpose machines, guys. Standard or general purpose. Okay. High mem means you will be having a lot of RAM. Mega mem means you will be having terabytes of RAM. Okay. Hyper mem, ultra mem. So these are different machine types that you have. See here, N4, N2, N2D, N1, E2, right? Day to day computing at lower cost. So we majority of the times we go for E2 machines, guys. In real time, in general purpose machine category, majority of the times we'll go for E2 machines. Majority of the time we'll go for E2 machines. You can pretty well find the differences of these machine types here. Okay. And the general purpose machine family, right? So you can see here memory comparisons they have given clearly, right? I'll just ping this link in the chat. I request you people go through it once, okay, so that you will get some understanding on the machine types. Okay, for now we are using N1 family machine, and we are using a general purpose called standard. Okay, and we are saying two means how many cores you need in that machine. Okay, for example, if I say N1 standard 2, that means you will get 2 cores in that machine. Okay, like in our laptops we have 8 core, 4 core, 6 core machines, right? Similarly, in servers also you have cores and RAM. So these two are the major things that you need to specify, right? So that is where you have this N1 standard 2, 4, 8, 6, right? And then up to 128 you have. That means in each server you can have 128 cores also. Okay, so here the thing that we are specifying is the N1 standard 2 machine type. This N1 standard 2 machine type will be having 2 cores. Okay, 2 cores and 4 GB or 6 GB RAM. That's it for each machine. So we are selecting 2 workers. Okay, we are selecting 2 workers. That means we will get 4 cores and 10 GB RAM. Okay, and we have a master machine with 2 cores and 4 GB RAM. Okay, so that is the configuration that you need to understand. So in when you are working with Hadoop and Spark, the cluster configuration is very important. You should calculate on the fly. Okay, so I have these many cores, this much memory, and I am processing this data. So I want to give these many resources to my job so that it will run faster. Okay, that is something that you need to know on the fly when you are developing your Spark applications. Okay, see here, our cluster is created within 2 minutes. Okay, our cluster is created within 2 minutes. In real time it will be more fast, but because it's a free version we are seeing this delay. But in real time it will be super fast. Okay, it will be less than 2 minutes also, because there you have properly configured the regions, locations. It will automatically go and pick immediately, right? But here it is a free version we are using, and then it is searching for the nearest compute available, right? So that's why it got delayed a bit, but it will be fast in your real-time projects. Okay, now here, once the cluster is created, you just need to go here and check your jobs cluster is created, the cluster name and the status is running, and the region, and the total workers you have is 2. So once you click on this jobs cluster, okay, so you will get all these pages, like your monitoring page, right? So what is your cluster memory usage, right? And node usage, CPU utilization usage, everything you will see in the monitoring page. And the jobs page, you can see the jobs and the VM instances. So what are all the machines that are contributing to this cluster, right? See here, one master machine and 2 worker machines. This is a 3 node cluster. We call it as what we call it as, we call it as a 3 node cluster. Okay, now one master machine, 2 workers. Okay, so you can go and check the configuration of these machines also. Once we click on here, uh, will be sent to the compute engine, which is actually the infrastructure as a service for GCP, right? So it will be pulled from there. compute engine, right? So instance ID, and then you can see the compute power, every detail, right? And the IP address, right? Everything you can see with respect to that machine. Okay, so that is the details, and that's how you can check the details of your cluster. Okay, once we have this cluster up and running, the first and foremost thing we need to go is we need to go and check the configuration, and then we can go for the web interfaces. This is where we'll try to communicate with the cluster, right? So we need some interface, or we need some medium to communicate with this data proc cluster. So that mediums we will find it in the web interfaces section. Okay, so once we go here, you have a Jupyter Lab, right? You have a Jupyter Lab, so you can go and click the Jupyter Lab. This Jupyter Lab will open up a terminal kind of a interface like your Vertex AI notebook. It will open up a interface to communicate with your cluster. Okay, so fine. So this will take a little bit time because it's still getting configured. So we'll first open the yarn. Why these links are provide access to connect to a web interface. Okay, let us see whether we'll be able to. Okay, so we're just going into the clusters and then web interfaces. And then I'm just trying to open this Jupyter. Yeah. So now we were able to open, right? Okay. So this is how actually we need to open your web interface for your cluster, right? So here you can open your terminal, right? So this is terminal will open for the master node. Okay, see here, -m, right? Miss master node. So you can communicate with your cluster. Okay, you can communicate with your cluster. So you can simply communicate with your Hadoop, right? So you can run your Hadoop commands. You can run your Spark things, everything, because you specified your image version, right? When you are creating your cluster, you specified your image version. So from that image version, it will pull all the details, which are Hadoop, Spark, Hive, all the services. It will try to install and configure it for you. So that is why I'm trying to communicate with Hadoop file system, which is HDFS, and then you can pretty well communicate and create Hadoop uh, directories and see what we have, right? Similarly for Spark, right? Spark. Just give me a minute. Okay. So fine. So now we created the cluster and we opened the Jupyter lab to understand or to communicate with the cluster, right? So let us quickly see whether our Spark installed or not in this, right? So Spark-shell is the command that we need to trigger to open the Spark command line interface. Okay, so this will give us a command line interface where we can actually write our Spark application command by command, and we can test it. Okay, so so our Hadoop is good, our Spark is good in our cluster. Okay, see here, Spark 3.1.3 is the version, and then Scala version 2.12.14. So this is Java 1.8 version, and then when you see Spark, right? So Spark developed in Scala language. Okay, Spark framework has been developed in Scala language. So that's why along with the Spark, we'll get Scala version also. Okay, if you don't want the Scala shell, you can pretty well go and open the PySpark shell, which is actually the Python based uh, Spark terminal. Okay, Python based Spark terminal. So it will open you a Python shell. Okay, and which comes with the Spark. Okay, this Python version it is using is 3.8. So you can write your PySpark program here. Okay, so you need to understand how to create the cluster. In cluster creation, what are all the things that we have configured, right? So you just need to identify that. I'm just pasting this cluster creation command, guys. Try to copy it and change your bucket, project, and service account information accordingly. So when you're creating your Vertex AI notebook, you'll see the service account details. After creation of your Vertex AI notebook, you'll see the owner here, right? This is your service account. Okay, this is your service account. So you need to copy this. Okay, fine. So any questions in the cluster creation? Any questions? Are we clear? Are we
Yes,
clear,
sir.
guys? Okay,
Yes.
fine. So okay, now we are good with respect to the cluster creation, and we know how to create the cluster, right? Just 1 minute, guys. Okay, fine. So okay, now we have a cluster. Now let us understand what is Spark, right? So we know how to create the cluster now. Okay, in GCP we can create the cluster. Okay, so and let us understand how Spark runs in this cluster, right? So what is Spark and how Spark runs, executes our application in this cluster. Now, before going to Spark, we need to understand our Hadoop kind of a framework, which is actually the distributed computing, right? So let us understand that, and then we will proceed to Spark. Okay. So in Hadoop, we have a concept called map reduce. We have a concept called map reduce. Before Spark, we have map reduce framework, which is used for data processing. Okay, which is used for the data processing. Okay. So in Hadoop, let me go for it. We will just touch base with Hadoop for a while, and then we will try to see why we need to go for Spark if we have Hadoop is there, right? So let us understand that functionality first. Okay, so in Hadoop, once we install Hadoop in a cluster, we will get two components: HDFS, Hadoop distributed file system, and then you have another component called MapReduce. Okay, so when we install Hadoop in our cluster, what we will get? We will get these two components, HDFS and MapReduce. HDFS is for the big data storage. Okay, MapReduce is for storage. Remember, if we want to store huge volumes of data, if we want to store different varieties of data, or set structured, semi-structured audios, images, anything, you can use HDFS service or HDFS component in the Hadoop. Okay, so HDFS is Hadoop distributed file system, which has developed to store big data. Okay, HDFS is a component for storage. Now we want to process this big data, right? So for that we need a service, so or component. So for that we have MapReduce. This is for big data processing. Okay, big data processing. Now what HDFS will do? HDFS is also a distributed storage. Remember, HDFS is also a distributed storage. Let us take an example. From the client you got a request for 100 GB file. Okay, 100 GB file. Now this master node will take that request and it will identify the worker nodes where it can store this 100 GB file. Okay, meaning it will split this 100 GB file into blocks. Remember, in Hadoop file system, each and every storage unit, physical storage unit, we'll call it as a block. Okay, block. Each block will be of size 128 MB. Each block will be of size 128 MB. Okay, each physical storage unit in Hadoop file system, HDFS, we call it as a block. Okay, and each block size will be 128 MB and it is configurable. You can increase that also. Okay, now your client wants to store 100 GB file. What your master node will do, your master node will split that 100 GB file according to your block size configured. Okay, so 100 GB by 128 MB it will do, and then it will get all the multiple different blocks, right? So it will chunk your entire 100 GB file into multiple blocks, and those blocks it will store in the servers. Okay, workers, let us say here b1, b2, b1 to b10 it will store. Okay, and then block 10 to block 20 it will store here. Similarly, somewhere block 21 to 25 it will store. So it will chunk your data and it will store it in multiple different nodes. Okay, it will chunk your data and it will store it in multiple different nodes. That is why we call it as a distributed storage. It is not stored in the single node. Okay, fine. Now Hadoop file system, we know. Okay, so it has a block component, and according to the block size, the input data will be splitted and stored in the HDFS Hadoop file system. Okay, guys, are we clear? Are you able to understand what we are trying to discuss? We are trying to discuss about Hadoop level things. Okay, because that is the first technology which came with the distributed computing. We need to understand that before going to Spark. Okay, so now, okay, so we have this data stored in a distributed fashion. Now we need to process the data, right? So we need to process the data. So this 100 GB file got loaded into Hadoop file system, and then we need to process it, we need to clean it, or we need to remove nulls, or we need to use some concat functions to derive the new columns. All these processings are there. Okay, so when you have all these processing, so what you need to do, you need to write your processing application, right? So your processing application, once you have written the application and once you deployed it, your master node, what it will do, your master node will take that processing logic and it will send that logic to your worker 1, worker 2, and worker 6. Okay, now what will happen, guys? In the worker nodes, your logic will be executed on top of the blocks that you have. That means your processing is also distributed and your processing is also parallel. Let us take an example. You are filtering the data, or you're applying a filter in your processing. Okay, now what it will do, your filter will be applied uh, in worker 1, and your filter will be applied in worker 2, and in the same time your filter will be applied in the worker 6 also. So your processing is distributed, your processing is also parallel, right? And your processing is happening on the chunk of the data, right? It's here, if you see, block 1 to block 10 only the data is there. So your logic will be executed fast, right? It is, you're not doing your logic on the entire whole data. Okay, you're doing it on the chunk fashion, right? So distributed way, parallelly your workers will start executing that logic. But here in your client server architecture, when you push a query, your query doesn't go to the data. Your data will be pulled from the server according to the query. Be very, very clear. Your data will be pulled according to the query from the server. But here, your logic or your processing logic will be sent to your worker machines. This concept we'll call it as a data locality. So you are not moving the data here and there, right? You are just sending the logic to the worker so that worker can execute that logic on top of the chunk of the data that workers have. Okay, now your processing is executed parallelly and all the workers will return the results back to the master node. Your master node will be coordinating all the workers and it will be monitoring all the workers stats. As and when it's request, it gets the processing request on a file, or as and when it gets the storage request on a file, master node will maintain a metadata management system. Okay, for this file, in what workers I have stored all the chunks, how many chunks I have for this file, and in what workers I have stored these chunks. When we are doing the operations on that file, again your master node will pick, okay, so this file is stored in these servers. Okay, I need to send the logic to these workers. So that is how your master node is very important in a cluster environment. If this master node goes down, your entire cluster will goes down. Be very, very clear. It is a single point of failure. Okay, but in real time we have alternatives and high availability mechanisms for the master node. So what we do, we maintain a secondary master node, and as and when it goes down, we'll have a secondary master node. That is a kind of method we will follow in the real time. Okay, guys, clear? Now this processing part, whatever the processing is that we are doing on the cluster, we have a component called MapReduce in Hadoop. Okay, MapReduce is a distributed processing framework. Okay, MapReduce is a distributed processing framework introduced by Hadoop technology. Okay, now here in MapReduce, we have a problem. Okay, why Spark got evolved? MapReduce is also a distributed processing system. Spark is also a distributed processing system. But MapReduce have some limitations and problems. That is the reason your Spark system got evolved, your Spark framework got introduced. Okay, now let us understand what are those problems. MapReduce can understand only the Java language. Be very, very clear. You cannot write SQLs, you cannot write your favorite queries on top of the data using MapReduce. Be very, very clear. You have to write a Java based program or a oriented logic to process your data. Okay, that is one first and foremost point. Okay, for Java developers, be very very clear. Okay, the second thing is MapReduce is good for big data processing, but there are some improvements that needs to be done from the MapReduce side, which includes the IO operations, the slowness in the processing, right? The slowness in the processing. How the processing is slow in MapReduce? Let us understand. You have data in MapReduce. You have three phases or two phases basically. One is mapper phase, another one is reducer phase. They are processed in a phase-wise fashion. Okay, so your input data will be pushed to map phase first, and after map phase the results will be written back to the disk. Okay, and then your reduce phase will read that results from the disk and process it, and then it will write back to the disk again. So your disk to disk IO operations in the map reduce framework are very heavy or very huge. Because of this disk to disk IO operations, your MapReduce framework is slow in big data processing. Okay, so what are these phases, right? So that is the framework, right? So your MapReduce framework, processing framework, we have to write three different logics. One is mapper logic, combiner logic, and reduce logic. Okay, these are the three different phases in your entire processing framework. Any application that you submit, you have to write these three classes: mapper, combiner, and reduce. Okay, because of these three logics or three phases, your output also intermediate for these three phases. Because of this reason, there are a lot of disk to disk IO operations in between in MapReduce framework. Okay, so that is the reason. Okay, it is very slow. Okay, see here, your processing structure of your map reduce, right? So you have one read from HDFS, again one write, and then again read, another write. So for every iteration, that means for every phase, your data needs to be read from HDFS and it needs to be write to HDFS. So that is where actually it is more it is more uh, slow in terms of big data processing. Okay, it is good, but what Spark is doing, right? So Spark is not doing this IO based operations. Spark is a in-memory computing framework. Be very, very clear. Okay. It will read the data once into the RAM. It is not a disk processing framework. It is a in-memory processing framework. Be very, very clear. Spark runs your jobs, or Spark, do the data processing inside the RAM. Inside the RAM. You know the RAM, right? So RAM will be more faster compared to your disk. So your Spark is a distributed parallel in-memory data processing framework. Okay, if someone comes to you and asks what is Spark, Spark is a distributed parallel in-memory data processing framework. Okay, so it will read data once into the RAM and it will perform all the processing logic you need, and then it will write data once at the end. There are no disk to disk IO operations. Okay, there are no shuffle between the phases, right? So that is why your Spark data processing is very fast compared to your MapReduce. So how much time you can save is more than 100% time. Meaning, if your MapReduce job is taking 1 hour, your Spark job can process the same data in 1 minute also. Okay, so that is the power of your Spark. So you need to understand the internal architecture of Spark, how Spark will do work, all those things. We will see them. No rush. Okay, we will go step by step. Today we understood we have seen the introduction or evolution of Spark, how Spark got evolved, and what before Spark, what is there. Okay, so how to create the cluster in data. We have seen a few things today, and if you see, there are differences between MapReduce and Spark, right? So we have discussed them. These are few theoretical differences. Okay, so uh, we can go through them for better understanding. We need to see the Spark architecture, how your Spark job will process your data in a distributed fashion, right? So we will see that, and we will see what are all the languages that you need, that Spark will support, and we will understand, step by step we will see the Spark things. Okay, so no rush, guys. We'll go slowly, and the understanding is very important here. Okay, so that's all I have for today. Any questions or queries? We will see the Spark architecture tomorrow, and we will understand the Spark APIs. What are all the data processing APIs in Spark, and how we will process the data in Spark? What is a Spark cluster, right? And what are all the Spark vocabulary, right? We'll see all those things in tomorrow's session. Okay. Uh, Mostly tomorrow I won't be available, guys. I'll inform you by today end of the day, because I have some important function that needs to be attended tomorrow, so I won't be available tomorrow, mostly. Okay. So we will connect back on Sunday. So this Sunday we will be concentrating on a 2 hour session, 1 hour a break of 15 minutes, and then on the next hour session. We'll be focusing on 2 hour session on this Sunday. Okay, wherein we'll complete the Spark things. Okay, and from Monday we will focus on deployment things, how we submit a job, how we submit a data proc job, all these things. So throughout the next week we'll be focusing on data proc only, along with the Spark. Okay, and the last week we'll focus on cloud functions and workflow, and then a project. Okay, that's where we'll finish off these sessions. Okay, any questions or queries? Please ask, guys. No questions?
Clear.
Fine. That's all I have for today, guys. Thank you so much for joining. Please practice your like, try to explore about amplitude, amplitude, right? So we will discuss Spark architecture in tomorrow. I mean, in Sunday's session. Okay. That's all I have for today. Thank you so much for joining.
Thank you.